While gold recovery rates depend on a variety of factors, from cyanide concentration to pH levels, the grinding fineness of the ore is one of the most significant variables in releasing gold minerals from their inclusions. To optimize this process, we need to identify the specific grind size that maximizes chemical extraction and then calibrate our milling hardware to maintain that standard consistently. The required materials for the baseline test include raw gold ore, a JT80 leaching mixing tank, sodium cyanide, lime, and standard milling equipment. Before beginning, ensure all operators are in full hazardous materials personal protective equipment. Sodium cyanide is extremely toxic and requires strict adherence to safety protocols. Starting without proper material preparation or safety measures introduces immediate risks to the facility and makes it difficult to achieve a stable, repeatable leaching cycle.
For the initial test, we pour the ground ore into the JT80 tank and add sodium cyanide at a ratio of 1 kilogram per ton of ore. We then adjust the mass concentration of the pulp to 33%, which provides the necessary consistency for the chemical reaction to proceed. Next, we add lime to bring the mixture to a pH of 11.5. Maintaining this specific alkalinity is necessary to stabilize the cyanide and prevent the release of toxic gas. The mixture must stay at a stable 18 degrees Celsius throughout a 24-hour leaching period. Once leaching is complete, we aspirate the liquid, then wash and dry the remaining dross to analyze its final gold grade and calculate the recovery rate. As the ore is ground finer, the gold leaching rate increases sharply as more mineral surfaces are exposed. Eventually, the curve flattens out. Finer grinding provides no significant boost, consuming energy for little gain. The optimal target is 325 mesh at 95%, maximizing recovery. Achieving that target in a production environment requires a shift from lab chemistry to a mechanical inspection of the crushing system and ball mill grid sieves. If the feed size from the crushing stage is too large, it can overwhelm the ball mill, leading to higher power consumption and inconsistent grind sizes. This also requires a close inspection of the classifier blades, which must be in good condition for the system to cycle material correctly. You can see the difference between a pristine, sharply angled blade and one that has been rounded and pitted by constant abrasion. As these blades wear down, they are less effective at moving material, which reduces the volume of returned sand within the classifier. This drop in sand return causes the overall grind to become coarser, pushing the material away from our 325 mesh recovery target. Even if your chemical mix is perfect, failing to maintain these mechanical components leads to a coarser product that inhibits the extraction process. To fine-tune the grind size, we must calibrate the height of the classifier overflow dam. Increasing the height of this dam expands the sedimentation area, which allows the machine to produce a finer overall grind. This crucial structural adjustment is made by welding heavy steel angle irons securely onto both sides of the classifier frame. We then insert precision-cut wooden glocks into these irons to set the dam at the exact height required for our target fineness. The final step is adjusting the classifier openings to properly manage the flow of material. If the lower openings are too large and low, the system is overloaded by an excessive volume of coarse sand returning to the mill. Conversely, restricted upper openings create a bottleneck, resulting in an inefficient cycle that slows down the entire production line. These openings should be set and secured during the initial equipment installation to prevent the grind size from drifting during production. With the machinery calibrated to match our testing data, the circuit can reliably produce the material consistency needed for high-yield leaching. By aligning the 325 mesh target with a consistent mechanical maintenance schedule, we create a process that balances high extraction rates with efficient energy consumption.